When it comes to meso compounds, these occur, meso compounds, because one of the stereoisomers that you get has a plane of symmetry. That's the whole point. So a meso compound is an achiral compound that contains still tetrahedral stereogenic centers. So students sometimes, pin it down to that. Anything that has stereogenic centers will have will be chiral. Not always true. One of those stereoisomers will be achiral because there's a plane of symmetry. So plane of symmetry trumps that for the again for this meso compound. So let me write that down so we have it. So again, we say one stereoisomer has a plane of symmetry. Of symmetry. And this will be difficult at first to see, but then when we apply our knowledge of conformations and how to rotate things, as you see down below, plus one last gift I will give to you in terms of telling which one will be the meso compound, then it should be, again, a doable topic. So I'm going to really just skip through the trouble. You can tell that the Cl is number 1. This comes number 2. The CH3 is number 3. So that would be actually an R. So I'm going to just simply tell you right away what they are so that we quickly move through. So this is R and this is R. So now I look at them. Did I switch any of them? Yes, I switched what? I switched to Cl. I switched to Cl, so that's opposite, opposite. So these must be SS. Look at the Cl here. Look how we switched it to the back. Did I switch to Cl here? Nope, I did not. So it's the same as this one. Again, in reference to this one, same. But it is opposite to this one on that side. So that will be RS. And of course, this one is opposite in reference to this one, remember? So this would be S. And as you would expect the other one, it would be an R. So these are enantiomers of each other, as you would expect them to be. However, this bond right there, when we get to this one, you might say, yes, I have 4 stereoisomers. However, when you actually take a look at one of these, let's say in this case, it's this one. And this one right here is actually in this in the anti position. Okay, it's in the anti position. If we switch this to the eclipsed, okay, so if we say we change to eclipsed, This drawing is not helping me here. Eclipsed. Yep, to the eclipsed conformation. Okay, just bear with me. The drawing here is not letting me, let's see. It's very slow. Yep, eclipsed conformation, meaning that I actually rotate this bond. Remember what we did in the last lecture. Rotate this bond, and I'm going to use blue. And move this up, move it up. Okay, or move it again about 60 degrees. We put that, move it 60 and 60 and 60 until we get to the eclipsed. You will see that the following is going to happen. You know, it's hard to visualize, but this is what's going to happen. And of course, if this one just stays the same, right here. So here it is after I made them eclipsed. Eclipsed means, remember this. And the Cl, and of course in the back, we're going to put we can put the CH3 right there. And then the Cl would be down here. And then the H right there. Okay. You see here we have a plane of symmetry. We have a plane of symmetry. This plane of symmetry makes this compound a chiral. So again, it has a plane of symmetry right here. And it makes this compound a chiral. Can you see how the plane of symmetry applies here? This side is equal to that side. If you say, okay, let me do this on the other ones, let me switch them. Okay, let me switch them. You can do a rotation. It's not going to give you a plane of symmetry on either one of these. These do not have a plane of symmetry. And of course, in this case, C and D are identical. And of course, they are superimposable mirror images. Okay, C are identical, and they are superimposable mirror images. So think about it, right? Where do we find this, finding the plane of symmetry through bond rotations? How do we do it? Well, if we have a Fisher projection, what you want to do is you want to do a 120 rotation. Okay, by a 120 rotation, basically what that happens is, to check if you have one, is you're simply switching, again, this, you have to think of it as, you're not switching atoms here, but what you're doing is you're doing a rotation here, right? You're doing a rotation, a conformation rotation. This would make the OH go right there, the CH3 in its place, and the H in its place. And if you notice here, there is a plane of symmetry. There is a plane of symmetry here as well. Look at the rotation. Rotate 120. And you rotate another 60, you will see that there is a plane of symmetry. Also, if you have the Fisher projections, you rotate 60 degrees in this case, they will again match, and there's again a plane of symmetry. So how do you do that? How do you remember? How do you know that? Here is the hint for you, and I want you to understand how to do this. Okay, so the helpful hint, and you'll thank me, an organic chemist, for this, is meso is never an RR or an SS configuration, but is either an RS or an SR configuration. What that means is, remember, you have the same atoms, okay? So like you can't have, like meso, there's no meso for this one. Like there's no meso here because these are different atoms. But if you have this, then you are likely to have a meso compound because, again, you have the CLs. They're the same. These are, again, different atoms. So these are the ones that you are looking for. And you look for a plane of symmetry. So meso is never an RR or an SS. However, it's either an RS or an SR. And both are going to be the same. So let's look here. Is there a plane of symmetry? Yes, there is. It's right there in the middle. Two equal sides. And if you do the configuration, which is done for you here, you'll get R and S. So the stereocenters are opposite, and they're arranged symmetrically. So this is going to be an RS, therefore it's a meso compound. Right here, the plane of symmetry would have to be would apply by, again, rotating, doing a rotation. If you rotate this, that methyl is going to come out. So they may not have shown it here, but I'll show it to you. And here's this group. So there's a plane of symmetry right there. So when you find out what is this RSSR, you find that this is an R and S, therefore it is going to be a meso compound. But again, look how there's a plane of symmetry. You need to look for that. Now we can change this and put like a Cl here, then there's no plane of symmetry, then there's no meso compound. Let's look at this. There's no plane of symmetry here. You can't cut across because they're not going to be equal sides. So you would have to check this. And if you check it, this is going to give you an R and an R. So it is not going to be a meso compound. Very well.